So as usual, I've just been making videos about stuff as I work on it. You can see a lot of people in the chat with me on this glorious Sunday, Father's Day. Happy Father's Day to everybody out there. Um, I am just going to be making a new project, and so I thought I'm going to do it. I thought I'd go ahead and talk to you about what's going on and what I'm doing. As you can see, I've got a number of things already stored in my GitLab, and the first thing you need to do to start a project is to create a GitLab repo. If you're on GitLab or GitHub, but preferably GitLab, go read about that. GitLab, actually, you can create a directory, and you can actually use that directory to just send it right up to GitLab and start a project right away. In fact, GitLab is the only place that you can start a project without even touching the website. So super cool. This is, I have a license in here, of course, the standard stuff you would have in most GitLab repos. And I put the GNU General Public License version 2. I'm a big proponent of that particular license. It's probably important for you to put a license in here, and you can do this through the GitLab repo. Through the GitLab tool if you want to do that instead. But having a license from the very beginning is kind of important. Make sure you know what you're going to do. If you want a permissive license, I strongly recommend Apache 2. It's by far the most trusted open source, progressive license, akin to MIT or BSD, which those both have problems. There's lots of code released under BIT and BSD, but if you're going to do a permissive license, there's a lot of really good argument to use Apache, and well, that's a separate video. But so then you got the license in there. I always think you should have a README in your repo. This talks about my knowledge management tool. I can go ahead and update it. This is all Markdown, so lots of videos on Markdown out there, including some from me. It talks about final implementation of Rust, which is no longer a thing. I just decided to edit another video to throw Rust out the door. Rust is just not fast enough. Sorry. Runtime might be a little bit faster, but writing in Rust takes a ridiculously long time. Not just because I don't know it, because the language syntax is really dense, hard to learn, and unnecessarily complicated. So I'm coding in Go. Knowledge management creation. So there, I'm going to get rid of that little thing. Here's some of the ideas for this tool, what it's going to do, can edit, blah, blah, blah. A number of these individual things. So I took some time and made a README of actually what I'm doing on the project. That's not specifically related technically to how you're going to go ahead and create a Go project. However, I do feel like it's really an important step. In fact, I'm a strong believer that you should actually write, if you can, you should write the test code first. To kind of decide what it's going to do, and how to organize that. And I'm going to talk about that a bit here more. So there's there's so many things we can talk about how to start a Go project. But the first thing you need to know is mod init. So go mod init. And this is not covered in any book currently because it was a part of 1.13 in Go, and none of the, including Head First Go, which I recommend, up to date on this particular thing. There are no good books on this. But you can, I think, what's it called? Essential Go. Is that right? I forget the name of it. There is one other resource for that. I can look those up for you later. But so go mod init. So go mod init, and then you have to give it the path that it's going to use on the internet, and that usually matches your repo here, which I have this long repo visible for you guys to read here, so you know what's going on. So that creates a Go mod file. And this Go mod file tells what module it is, what version of Go you're using. I've got the latest here, and eventually this is going to be a place to list your dependencies and things like that. There's also a really important directive, and if you forget, and later on when you need it, and you hear about me saying it in this video, you'll remember it. So make a note that you probably will need something called a redirect, and what it does is it's a replace keyword, and what it does is it allows you to do multiple concurrent package development efforts at the same time without requiring you to pull down public repos and stuff like that. There's some other things you can do there to allow private development that are not the defaults, and this is something beginners trip up on a little bit, particularly advanced beginners. That's a thing where you're trying to develop more than one package at the same time, and I tend to fall into that category. and I didn't know about replace for a very long time. So I'll do a separate video on replace when we need it. But right now, just know that that's a thing, and remember to come back on it. So yeah, you guys are arguing about languages. We're not going to talk about that right now. So Subpoena Gallery, don't bother them. They're good people though. When are we not? I know. That's what makes this little vibrant community so great. We can respect each other and disagree vehemently until we arrive at a good point together. So here we go. I'm going to go ahead and we got everything ready to start our application. We got our license to README. We have this thing. There's no concept of like an SRC directory. You'll see some package management documents out there, and there's actually one GitHub repo that professes to be like the the end all example of things you might end up putting in your Go directory. Part of the reason that this all exists is because there is no canonical specification for how you should put stuff where, other than Go mod, right? And that leaves some room for adjustments. Yeah, for client statements, thank God. just that reason alone is enough. And so let me just say, there's basically two things you're kind of making here. You're either making a command, a quick and dirty Go command, which usually you would use shell for or something, in which case you're almost always going to have a main.go in here, in my opinion, or you're going to make a package, and I want to show you how to do both of those real quick. So the first of them is to just make a basic main, command, main.go, and when you open it up, you'll get your main.go. You can do package main, and I don't have my, do I? Yep, no, but I haven't. So then, you can just do your func main. I'm going to screw this up because I've been coding in shell for the last 2 weeks, and then Rust for the last 2 days. So it's going to be hard. And you'll see that I've got a two space indent. Again, yeah. So the first thing you're going to notice is that when I tab, I have two space indents set. The standard requirement for all Go code is to use tabs, but never fear, nobody ever types a tab into their code. And so here we go. We've got package main, and there's a secret here. There's actually a println statement. It's buried and unsupported in Go. But we can go ahead and use it for today. So hello world. I use this println all the time when I just want to put a quick and dirty print statement in there that I really don't want to leave in my code long term, because then I can quickly find them, search for them, and delete them later. I use print statements for debugging a lot. I think a lot of developers do, even though they don't like to admit it. So how do I build it? So go build. If I wanted to just run it, I could do go run main.go, and that'll just run the command. Did you notice it compiles and runs faster than a Python script? The Go community and the Go developers and original designers are very proud of their compilation speed. In fact, so much so that they, rather than using angle brackets for generics that are coming, the leading proposal right now has parentheses because it's easier to parse, because they've already worked it out into their tokenization of the thing, which is just crazy that they would make a decision like that based on how fast the code compiles. Yeah, so you can actually go ahead and just run stuff like that, and there's nothing wrong with that. Another thing though, if you wanted to build it, you just go build main.go, and that will build out a program that matches the file name, which is unlikely to be what you want. In fact, you saw I run pretty fast too, right? In fact, Go runs so fast with Go run. There are people who write Go scripts. I kid you not. They write Go scripts. And they run them with shebang lines that are Go run, which I can't recommend to you. That's not the way it was designed, but it's really interesting that that's still faster than Python. So anyway, we're going to go ahead and remove this one. So if you just do Go build by itself, Go build, that'll build out a binary, as you can see, that matches the name of the parent directory, the containing directory. So now we have hello world, and it just runs. Another thing you can do though, and this is so easy, is you can do Go install, and so for long as you've got your Go set up, which we're not going to talk about here, but if you got your Go set up properly, it will put it into your binary, and then I can search for KN, and you'll see that the kn that lives in .local go bin kn is the one that's gonna go, and that happens to be in my go path, which I have set in my environment. And it's really the only thing you need to set. If you set a go path, it will look for the bin directory in there and set that. So that's something you might want to add to your environment. While I'm on it, I might as well just talk to you about it. So if you want to set up your environment properly, let's see if I can find mine. Bin go. I got my install. Common directory. Nope. Oh. Well, I'll do that in another video, and I'll just cut this part. There's another here. There's another. These are going to be hard to read. Yeah, forget I said anything. So it's like my broken environment because it's got all my colors in there. Clip. All right, I'm going to clip that part. New programmer. What should I learn as a higher level language? Python or Go for sure. Go and Bash are my recommendations. JavaScript, Bash, Go, those are my major recommendations. Eventually you need to learn C and Rust. All right, so there you go. Try Control L. Are you serious? Oh, look what Control L does, people. Yeah, just set up C to clear your screen. That's one of my pet peeves. That's why he's having fun with me. So here we go. So here is your main. Before we leave this, so let me just recap. So to run it, you can just do go run main.go, and it doesn't create any artifacts. You can build it as it is, and it will build it with the name of the file, which is very unlikely. Usually you're going to need dependencies to be built into it, so you can't do it that way, and that requires you to do it this way. Go build, which will then pull everything that it depends on in and make you a .kn directory, file to be run. But if you don't want any of those artifacts there and you want it to automatically install it into your Go path, which you've set predefined when you install Go, then you can go ahead and do go install, and that will show you that you have a kn tool living in your binary directory, all of which can be run. I tend to stick with go install. In fact, I have an alias for Goe, but it's not on right now, just because I type it so much, and I don't use a different kind of IDE or anything. I use tmux plus VI for all my development. So that's covered in a different video, but that's why you'll find me doing this. I was raised on command line development, and even though I used VS Code for 2 years for a lot of web development, I've returned to Vim. Another video on that if you want to watch that. So this is just kind of how to get going with Go. I know that's like so lame, right? All those like puns, but it's valuable. There is one last thing I want to tell you about though, and that is if you're not making a command. If you're not making a command, then generally speaking, so let's say I want this to be a library. Okay, so we're gonna first of all, if you're I'm just going to remove it. So we're starting out, we want to make a kn library. That means it can be imported with the Go, the import statement, and say import gitlab.com/rdbx.gg/kn. I want to import this this knowledge node thing. How would that happen? Where would you get it from? Here is we can do usually in that case we would make a file. There's no canonical way to do this, but very commonly you'll see a file that matches the name of the directory, because the directory is going to take generally speaking, you want to keep the package name the same as the directory, although there's no requirement to do that. You could name the package something entirely different, and we're going to do that now. So kn.go, so instead of package main, which every command has to have, we have a package, only this time we call the package kn. All right, now I could have that package be George, right? And I could import gitlab/rdbx/gg/kn. That would be my import, but when I went to use the package, I would have to type George dot for everything, right? So in this case, I don't want to do that. I want to type package kn, and because I want it to match. Sometimes people will do like kn-go or something like that. There's no rules there. The main thing you just need to know is that you generally have a package instead of main. Well, you always have to have that, but you don't have I like to keep the package name the same as the directory name. Some people will say we'll do a lib. We'll do lib.go because that gives you a visual representation right away that it's a library, and that's the main. So lib is basically the main name for the file. You can have multiple files. By the way, in a Go, you can have as many files as you want, and all the files that end in .go are all as if they all existed together in a single large file. There's no scope separation or anything like that that exists in other languages. So it's just the only purpose for separating out a file is for functionality and maintainability, and maybe to match up with test cases, which we'll cover in a different video, which are built into Go. By the way, anything with _test is considered a test for a specific thing. For modularity, yeah. So that's what you got here. So in this case, there wouldn't be a func main, right? Because that doesn't make any sense because it's a package. So what I could do here is I could make something a library. You don't have to have a directory structure to make something a library. No, absolutely not. You can. No, you absolutely don't. In fact, a lot of smaller libraries will just use the top level. Here's why: because when someone goes to, I'm going to show you, we're going to do it. But when somebody goes to use your library, they're going to have to type all of that path in. So you need to really give a lot of thought to what that path is, because people are going to be hard coded into your dependency path. It's also a reason for you to give a lot of thought about where you host your library. So if you're just making a command you're going to use, that's one thing. People can pull down your command and use it. But if you're making a library that people are going to build dependencies on, give a lot of thought about what you name it, where it lives, when you're ready to tag the thing, and those are all stuff outside the scope of this video, but they're super important things to consider, beginning with what you name the thing. And I'm going to show you why. So we're going to make this a library. So even though I don't like the func keyword because it's a procedure or a subroutine, I'll get over it. We're going to go ahead and make it func. Here we're going to say, I want to say, I don't know, let's say greet. Okay, so we'll have a greet function. It's your first introduction to functions. I think what teaching Go is you have to throw everybody right into functions right away, because everything you have to have a main function. There's no like teaching variables and assignment and data types and all that stuff before functions, because you can't even code without a function. So we have a function here. I'm going to go ahead and put it in the greet. I'm going to say, in this case, well, I'm pretending here. I'm going to throw this away. This is not part of my actual project. But if I was going to have a greet, I want to, well, let's just say for simple sake, we're going to say, I want to just say print hello. There's no void return or anything. It's just if there's nothing there to return, it'll be fine. And you don't need a return statement at all if there's no return value. And there's no sort of last line as your return value, which is my greatest pet peeve with Rust. Out of all the things Rust could have done, that is the one thing that I'm the most triggered by. Anyway, I do need an import. Yep, but it's going to add it automatically, hopefully. So I'm going to do fmt println and hello world. I don't know if my Vim plugin is configured properly right now, but normally, there you go. See, I saved it. See that? Pretty cool, huh? So normally when you use a package, if you have the right Vim file, and when you watch this, it'll actually take it in and out. See that? So, and then I comment out so Go is very picky about unused imports. It won't compile if anything is being imported that's not being used. So you have no idea how valuable that single feature is of turning on and off imports automatically for you. It's super valuable. All right, I'm using Fatih's Vimgo, yes. So you got this going on. You're doing your hello world, and that's fine. So how do I run the thing? First of all, a couple things you need to know. Because if I had made this lowercase greet, nothing could use it, because this is something really, really cool about Go that kind of falls into the cute category, but it totally works. So when so when you type a capital G, that automatically exports that symbol. And I say symbol because in this case, the symbol is a function. For those of you who know computer programming, symbols can be anything, variables, pointers, whatever, anything that's, got a name basically. And so to export, rather than like in Java using, export, there's nothing to type there. You just make it a capital. I mean, how cool is that? I love that. It makes it easier to read, and believe me, if you use any other language, you know what a big savings in developer time. Just that one really intelligent decision was. God bless those three. Pike and Thompson. That's the wrong way of forced name syntax. No, man, I love it. I love it. Yeah, a lot of people don't like that because they've been writing in other languages for a long time. I think that is one of the most brilliant decisions ever made, because it is. You know why? Because it makes me a faster programmer, and it makes my code much clearer to read. But people, brutal typo to make. Yeah, it is a brutal typo. Thank God, right? Visual Basic syntax. I wouldn't know. I've never coded Visual Basic. I coded Basic, but not Visual. That was my first language. So anyway, yeah, I did not. There's a lot of things about Go that I didn't like at first, and now I like. In fact, it's influenced me so much that I actually now use upper cases in my YAML, and you guys are going to yell at me, but I don't care. I use YAML with initial caps, unless it's a localized thing. And I can't tell you how useful that is in terms of maintenance. And you can disagree with me all they want. It's a free world. I can do what I want. And so I use uppercase for all of my YAML data that is meant to be used by others. If I have like inconsequential, stupid little things, I leave it lowercase and I put X in front of it. That's a convention that I've used in my massive amount of like knowledge, YAML data, to keep good track of what it is. Another thing that's really nice about this is because I'm using the uppercase, I don't have to do any tag association in Golang, and we haven't even got there yet. But by doing that, I can actually import and unmarshal that YAML data directly into structures with no function calls. Yeah, no function calls. It just unmarshals automatically right where it's supposed to be. And it's super great until it's not. Sometimes you'll like miss the thing and you'll get an error and it won't unmarshal and you're like, well, what part am I missing? So, this is all stuff that we'll get to eventually. I'm going to be doing a lot of code on stream. So anyway, we got this greeter code and I don't know how to test it. So I'm actually going to teach you the fastest way to test this, and I want you to get used to doing this. Your first instinct might be, I need to make a main program that uses it. No. Your first instinct should be write a test case just to test this one little thing, even if all it does is run the thing. And so the first instinct should be, I want to make a little bit of code to test. Decision, generally speaking, 9 times out of 10, you want the package to be the same name as the package with the word test after it. That is just to create an independent package from the other one. And the reason you're doing that is so that it forces you to write code that looks like somebody would be writing. So this is another one of the brilliant things about the Go design that has nothing to do with the syntax. It has to do with the workflow that these guys have really thought about. So what it means is that when somebody comes to your code, they can immediately look at the _test files and see exactly how your code works immediately. So much so that you can even use a special keyword called example, and you can write runnable examples, which are also test code, which can also be run dynamically through the playground on a website that's documenting your code. It is so amazingly well thought out. I just can't tell you. And it makes you a very effective, very fast programmer, which trumps runtime speed in my book. All right, so we're going to do this. We're going to put, so how am I going to do it? So the most basic test would be, that's not an example, which I'll do another day. I'll just do a basic test. Oh, see how, oh God, I didn't know they added that. So there's been a long-standing convention. Yeah, thanks for catching that. There's been a long-standing convention of adding a blank space between the imports and the native libraries on the top, which is very nice because it'll sort all that for you and everything. And this is doing it for me. Check this out too. It actually made this into a tab. I have 2-space tab stop set. I have not typed a tab the whole night, nor have I typed. In fact, even if I type tab with 2 spaces there, it'll either insert a tab. Actually, Fatif Vim is putting a tab there for me instead of something else. But even if you use spaces, when the thing exits, it'll write it properly and it'll put the tabs where they need to be. And you don't need to really fret about that. It's one of the biggest complaints people have against Go is the use of tabs. Blessed with awesome bandwidth. Are you kidding me? I am so sorry, people. It's not called KN_touch. I'm gonna leave that in just so you can see how dumb I am, just like the rest of us. So this should work better. All right, much better. Hello world pass, and it went ahead and printed it out. I didn't have to run print. I didn't have to make a command to run it. All I had to do was make a test case, and the test case runs the thing. There's t.log and there's t.fail, which are really great for doing this kind of testing. You can actually do some other testing, but that's going to be its own video. All right, so sometimes, and this is the last thing I'll put here on starting a project, sometimes you want to actually, I do have a, yeah, thanks for the check. Sometimes you might actually want to combine a package with a command. This is a rather common thing. And there's a number of ways to do this. But what I feel is probably the most standard way to do it, because you might actually want to have more than one command included in what you're doing. And so it's even though I said it's not canonical, that means, you know, it's kind of your own thing to do. You can go ahead and type make directory cmd, and so the cmd directory has become sort of an idiomatic way of putting in commands. And so then you also within there need to make the name of a, because, you know, when you're building, it uses a directory name to give you the name to your application. You can go ahead and make a name in here. So I'm going to make a kn in there. And in this case, I'll have both a kn package and a kn command. And so when you do this, you can go ahead and put it in here, and inside of your tree cmd, you can see I've got a thing there. So let me just tree the whole thing. As you can see, you know, it's kind of buried down there. It's not particularly easy to get to, but it doesn't make it possible for you to have commands that are also with everything else. So what you would do is you would then you can do what we did before, which is cmd. I'm going to edit it from up here. You'll find out later. It's just easier to build from here. And then you can do main.go. So from up here, you have it now. Did you see that? Did you see that? Did you see how it made this automatically for me? I didn't make that. Let me just, that is what the Vim plugin will do for you if you follow that convention. It will detect that you want to make a command, and it will take care of a lot of the extra work for you. It's the kind of thing you're probably used to seeing in VS Code. By the way, Go has a very, very healthy VS Code community. Recently, I had a friend that I've been mentoring and helping out get hired for a company that does Go programming. I won't say which, but the guy that interviewed him ran VS Code from Go, and he used Vim. So, you know, it's one of those things. The really great thing about Go is you're getting people from all over coming to it, including even machine learning. I just read a whole blog about how it was the best pick for machine learning. Yeah, not Python, from a guy who was in machine learning, like one of the core people. And because TensorFlow is now available in Go, I think, and a number of other reasons. In fact, Go is displacing Python on a number of fronts because of its ease of use, ease of writing, and, you know, wicked fast C speed, static linking, cross compilation. I could keep going on and on and on and on. All right, so and that's why I like it. I don't like it. I love it. I keep forgetting. Every once in a while I get attracted, you know, that meme where the guy's looking over his shoulder. Well, that was me with Rust for the last 2 days, and then I'm back to my Go, man. It's like, yeah, it's Julia. Yeah, oh God, yeah. Julia is a fantastic language to challenge Python on the science front, right? Yeah, so it's going to be really great. So this has been sort of just a kind of a get you going kind of thing. One last thing though, let's actually compile and install our command. So I can just do go install, but this is a little bit trickier. I have to do a / here. If you don't do that, you'll get a problem. And you just have to indicate what folder you want, but you see how I can't find it. So I need to do this. I need to go into / and that will should load it. No, what did I do wrong? Go install should have worked. Oh, / no. What's going on, people? I got a problem. I gotta fix it right now. FMT import main vim go print vim go. I don't know what's going on. Why is it not building? Can't load package kn. Oh, I know why. No go files in. Yes. Oh, I think I know what's going on. Command in kn, command kn. No go files in. What is going on? I know it should work. It's like freaking me out. Why is that not working? Keep working. I know that works. I just don't know why it's not working right now. No, it's not going to install. Yeah, somebody out there smarter than me, remind me. Oh, I never saved a file in there. Silly me. Silly me. You know what? It can't compile it because it's not there. I'm so stupid sometimes. So, you know what happened? I got all excited about the fact that this automatically added the thing I forgot to do. Save. Such a screen. Let me make sure it's there. Yes, there it is. Okay, so now we can do that. So here we go. So there we go. Let's see here. I see a language war about to erupt. Let's see if I can get my go command to build. There we go, and I can do kn and it prints vimgo, which is what the vimgo utility decided to put in there. That's it. This is how you create a Go project. How you get started. It's actually relatively easy. There will be, if there's not already, there'll be a separate video on how to install Go and do all of that. And then this video will be a follow-on to that. I'm going to go ahead and put a mark in this. See you later. Stay tuned. Keep coming back if you want to have some more Go programming with us. Or maybe you want to join one of our open source projects and put that on your resume. We would love to have you. Please consider it. We can remake the README world. A world not dependent on JavaScript for knowledge. All right. Talk to you later.